Okay, time for day 8, 7/14, December 8th. Let's hop into it. Expedition comes across a peculiar patch of tall trees all planted carefully in a grid. The elves explain that a previous expedition planted these trees as a reforestation project. Now they're curious if this would be a good location for a treehouse. First, determine whether there is enough tree cover here to keep a treehouse hidden. To do this, you need to count the number of trees that are visible from outside the grid when looking directly along a row or column. The elves have already launched a quadcopter to generate a map with the height of each tree. I see. Each tree is represented as a single digit whose value is its height, where 0 is the shortest and 9 is the tallest. A tree is visible if all the other trees between it and an edge of the grid are shorter than it. Tree is visible if all the other trees between it and an edge of the grid are shorter than it. Only consider trees in the same row or column, that is, only look up, down, left, or right from any given tree. All of these trees around the edge of the grid are visible, since they are already on the edge. There are no trees to block the view. In this example, that only leaves the interior 9 trees to consider. The top left 5 is visible from the top and left. Right? The middle 5 is visible from the top and right. Yep. Okay, I think I get the gist. With 16 trees visible on the edge and another 5 visible on the interior, a total of 21 trees are visible in this arrangement. Consider your map. How many trees are visible from outside the grid? Okay. This is becoming standard procedure. All right. I think a pretty simple way to approach this would just be create another array of the same size and have 0 indicate the tree being hidden, 1 to indicate if it's visible. So maybe let's try that. Visibility matrix equals, it's just an empty array for now. For I equals 0, I is listing length, and input dot length plus I, visibility matrix dot push new array 0 0 dot length ts initialize array. Typescript 0 initialize array. 0 fill array. That could work. New array of size line length dot fill with 0. Cool. Okay, that's what I was wanting. Now we're going to iterate through every item in the visibility array. Oops. If j is 0 or I is 0 or j equals is matrix I dot length minus 1. So if we're in the final column, or we're in the final row, then we will set is matrix ij equal to 1. Now let's log the matrix again. Perfect. So now we need to explore the interior trees and see if the tree is visible or not. So So we have 4 approaches that we can take for any given tree, from the top, left, bottom, or right. Let's first just consider a top approach. That would be let cur tree equal input ij. So that's what tree we're inspecting. And then for let I checking from top, I equals 0, I is less than maybe we could have some better names here. Check I, check j. I is less than cur I plus I. Let visible equal false. I think that will default to setting it false. And then we'll run through all of these different visibility checks. If any of them return true, then we just return from the function without having to do the rest of the checks. So here, let's see. If input ij So if we ever make it out of one of these checks with visible equal being true, it means that we pass the test and we can return true. If visible, return true. Okay. So now let us perform checks from left, and this will be j equals 0, j is less than current j, plus j, current I, j. What's the problem? I put my parenthesis in the wrong place and did that before duplicating. Naughty naughty. But that should fix it. Okay. Check from bottom, check from right. Might make more sense to group the vertical checks with the vertical checks and the horizontal with the horizontal. So I equals input dot length -1 is greater than current I minus I. There's a ton of possibility here for copy and paste mistakes, but I'll try and be methodical. So we start at the bottom of our input length -1. We start there. We go until I is equaling current I, so up until the current line. Okay, so far so good. Input I, current j is less than current tree, visible is true, visible is false, break. I think I could have inverted some part of this for loop logic so that I don't have this kind of dangling check for visibility, but it works and I understand it enough, I think. Okay, the bottom check looks good, so now we check from left. Means j is 0. We go until the current j. Increment j is less than current true, visible true, else visible false. That one looks good as well. J is greater than current j, minus j, current I, j less than. Cool. I think that's pretty decent. Let's give some bogus types to. I'll actually give them real types. Input can be array, array still just a string. So let's do mm, 96. Tree is visible. Input. Sweet. So we have the 16 around here and then 5 interior visible trees, so it looks good. What if we reduce basically kind of tired of reduce. It doesn't ever work for me quite as I want. So let none visible trees equals 0. Then we'll do this the trusty double for loop construction. If vis matrix I j equals 1, then we increment non-visible trees, and then console.log number of visible trees equals numviz trees. 21. Okay, now let's try it on our actual input. 1832. That's the right answer. Continue to part 2 after 24 minutes. Part 2, content with the amount of tree cover available. Content with the amount of tree cover available. The elves just need to know the best spot to build their treehouse. They would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up, down, left, right from that tree. Stop if you reach an edge or at the first tree that is the same height or taller than the tree under consideration. Okay. The tree is right on the edge. At least one of its viewing distances will be 0. Okay. The elves don't care about distant trees taller than those found by the rules above. Don't care about distant trees taller than those found by the rules above. The proposed treehouse has large eaves to keep it dry, so it won't be able to see higher than the tree. Treehouse. Okay. Consider 5 in the middle of the second row. Looking up, its view is not blocked. It can see 1 tree. It's because 3 is less than or equal to 5. Looking left, its view is blocked immediately. It can see only 1 tree of height 5 right next to it. Looking to the right, view is not blocked. It can see 2 trees, because both of those are less than or equal to 5. Looking down, its view is blocked. Eventually, it can see 2 trees. 1, 2. One of height 3 and then one of height 5 that blocks its view. The tree's scenic score is found by multiplying together its viewing distance in each of the 4 directions. For this tree, this is 4. However, you can do even better. Consider the tree of height 5 in the middle of the 4th row. That tree's scenic score is 8. This is the ideal spot for the treehouse. Consider each tree on your map. What is the highest scenic score possible for any tree? Okay. This is definitely going to be a duplicate and reassess my strategy. So day 8, part 1, day 8, part 2. Now, I don't think that we auto-initialize edge trees to any particular value. We just want to calculate the scenic score for that value. So, this matrix ij equals scenic score of let input ij. Okay. So now we kind of are going inside out. That left score equals 0. Right score, top score, bottom score. Then it equals 0, minus. Okay, so we start at the row above where our current tree is. We iterate through the rows until we reach the top row, until we finish processing the top row, actually. Cool. And then for the bottom, start with current I plus 1, I is less than input 0.length, just input.length, and plus I. This assumes that all lines of the input are the same length. I think that's fair. If input I current J is greater than, is less than or equal and we're going to add that to the top score plus equals tree score is less than or equal to the current tree, and top score plus equals that tree score. However, else if tree score is equal to the current tree, in this case we still add to the top score, but then we also break out of this for loop because we won't be able to see trees beyond the tree that is the same height. Hopefully that makes sense. And then otherwise we just break and we don't add to our top score. So let's try and adapt this to our other cases. Oh. Tree score to current I. Oh, no. That's right. Cool. And we will return top score times bottom score times left score times right score. Wow, that's a big number. It's also not necessarily the right answer. I think it's because we don't add the tree score itself, we just increment by 1. So plus plus. Okay, this is closer. But this one should be registering as 8. Why isn't it? Clean this up a bit. Oops. I'm gonna dive into the black box here. If we're at row 0, 1, 2, 3, column 0, 1, 2, if I equals 3 and j equals 2, then let's console.log. Two one two one. It needs to be 2212. So the top score is 2. That's correct. Left score is 2. That's correct. Down score is 1. That's correct. So the right score is what's not working. It's registering as 1, but it should be 2. Let's see if we can rectify. 3, 4. Console log tree score. We should be seeing 4 and 9. Okay, if we encounter a tree that's larger, then we still increment. Okay. A slight misunderstanding of the directions. If we see a tree that's taller, we still count it, and then at that point we stop considering more distant trees. So I'm going to update the logic on the rest of these. As left score plus plus. But now I've gone too far. And now I've gone just far enough. Great. Max score equals 0. Double for loop construction. If viz matrix ij is greater than max score, then we assign max score to that value. And we want to return, or just log out, ideal scenic score is max score. Cool. Let's crunch the numbers. 46 minutes elapsed. Looks like my algorithm is not the fastest in the world. And we're getting this. I'm curious if edge trees should have a visibility or a scenic score of 0. It's viewing distance in each of the 4 directions. Okay. Yeah, it looks like that's true. Nice. Well, that's day 8 in the bag. Now I can finally rest for 15 hours and pick up tomorrow. Cool. All caught up. Thanks for watching.